As you take a look at these three expressions, we need to be able to understand what each of those is actually talking about. Now, no, when we see that, that does not mean sin. And we don't read this as cos and we don't read this as tan, even though we might be tempted at times to get a little bit lazy about it. Really, that's not what they mean. This sin here is actually just an abbreviation and therefore the function name for sine, which is why, because it's a function name, that you see us write it like this, where you write sine, S-I-N, the abbreviation for sine, and then parentheses x. Just like if I have a function f of x, remember I put the letter out front and then I put whatever's in the function inside parentheses here. It's the same idea with these because these are functions. And so then cos here stands for cosine and tan stands for tangent. Each one of these really represents a different ratio of sides in a right triangle. Let's take a look at what I mean there. So let's take a look specifically at what cosine is. Now cosine is defined as the ratio of the adjacent to the hypotenuse in any given triangle for a particular angle. So in this particular example, I'm going to use the fact that cosine of 60 degrees equals 0.5. Now, one possible triangle that this could be describing is this one right here. You'll notice here that we have a 60-degree angle, the adjacent side length is 1, and the hypotenuse side length is 2. And so then if I wanted to figure out what the cosine of 60 degrees was, I would do the adjacent, which I found was 1, over the hypotenuse, which I found was 2. And 1 over 2, of course, equals 0.5. So that's why the cosine of 60 degrees there does in fact equal 0.5. But the interesting thing is it's not just with this particular triangle. It could also be describing this triangle at the moment. Notice the ratio of the adjacent to the hypotenuse is still a half. Because if I did 2 over 4, I'd still get the same thing. And if I take a look at other triangles that I could build with a 60-degree angle, I would always find that that adjacent side is half of the hypotenuse, which is why cosine of 60 degrees will always equal 0.5. Now, there are, of course, all three of them, right? We have sine, cosine, and tangent. These are the definitions of all three of those. So sine is defined as opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, when we're talking about all those different sides, this is what we're talking about here. We're going from any given angle. Notice in this particular problem, this is the angle that's been marked down here. By putting that little arc in the angle, we're showing that's the one that we're going from. That is critical because if it was this angle up here, it would change which one was the opposite and which one was the adjacent down here. All right, so going from this particular angle, notice the adjacent is the side that is next to the angle. The adjacent side is always touching the angle that we're working from. The opposite is on the opposite side from the angle. The opposite side does not touch the angle. It is the only side which does not touch the angle. And the hypotenuse is always the hypotenuse. The hypotenuse, as you may recall, is defined as the longest side length in a right triangle. It also is the side that is opposite from the right angle. All of those are different ways of remembering it, but realize that going forward, you will have to be able to identify which side is which. Now, one of the trickiest things that we have in terms of these three different trig ratios is that we need to remember them because we need to actually memorize that sine is opposite over hypotenuse because it comes up so often we need to very quickly be able to go to it. This is one of the few real memorization pieces that's really worth putting your mental energy into. So the nice part is that because it is so important to remember, we have a memorization device here. SOHCAHTOA. Now, what does this really mean? Well, each of those letters actually represents a word. The S stands for sine. The O after it stands for opposite, and H stands for hypotenuse. Why? Well, remember that sine was defined as being opposite over hypotenuse. Notice that definition is right here. Sine is opposite over hypotenuse. And so if we remember how we spell SOHCAHTOA, we remember what the definitions of all of these various trig functions are. So like the C, well, that's telling us about cosine. A and H, that's our adjacent and our hypotenuse. Therefore, cosine is adjacent over hypotenuse. And the T here stands tangent. And tangent, you notice the O and the A. The O and the A there are the same things that O and A were up here. It's opposite and adjacent. So tangent equals opposite over adjacent. And if you can remember SOHCAHTOA and how it's spelled, then you have this nice way of remembering the definition for sine, cosine, and tangent. But of course, if you're looking at it and say, okay, I got that memorized, but I still don't know what the opposite side is, that would be a problem. We really do need to be able to look at a picture like this and be able to tell which side is which. And so these side lengths and names, by the way, remember, these are only for right triangles. This is where sine, cosine, and tangent come up. They only come up in right triangles. So these names are only used with the right triangles as well. But let's actually take a look at how we could identify which one's which here. Do a little bit of practice with that. So here we have a triangle. It's been named for us. A reminder about naming conventions when it comes to triangles and such. You notice capital letters are used for our vertices, and lowercase letters are used for our side lengths. And the letters that go together are opposites from each other. And that also will help us in doing this problem, because in this one, we're told that we are going from angle A, and we are then going to name each side. So going from angle A, the first thing I'm going to do is I'm going to mark that on my picture here. That way I can really see where it is. If I were doing this on paper, I'd put my finger on angle A so that I could really see where the triangle is building from there. And then if I want to first find the opposite side, I'm going to think about, okay, well, what's on the opposite side of the triangle from that angle? It's literally as far away from the angle as we can get. Notice that is side A. Now keep it lowercase, because capital A, remember, is the vertex. It's the angle. Whereas lowercase a is the side length. All right, the adjacent. Well, the adjacent is the side that is next to the angle, but you could be saying that either of these two sides is next to the angle because it does touch both of them. So a nice way to get around that, at least at first while you're getting used to this, is to skip ahead and go to the hypotenuse and then go back to the adjacent after that. Because the hypotenuse is the longest side. Or you could also think of it as the opposite side from the right angle. So you notice then the hypotenuse is side B. Now, all of these are always going to be different sides, opposite, adjacent, and hypotenuse. So we can actually figure out what the adjacent is now by a process of elimination. It must be lowercase c, that is side C right here, because that is the side that the angle is touching, but which is not the hypotenuse. Let's go ahead and do another one. Now notice, this is the exact same drawing that I gave you last time. The only thing that is different between this problem and the last one is that here I'm saying from angle C. So the first thing I'm going to do is I'm going to mark that so I can see it. That way I don't have to keep trying to remember from angle C. I can see it just by looking at it. And the first thing we're asked about here is the opposite. So if I look for the side that is as far away from angle C as I can get, that is, it's on the opposite side of the triangle, notice it is side C. So by going from a different angle, it changed what the opposite was. All right, next up, I'm again going to skip the adjacent and go straight to hypotenuse. So the hypotenuse is the longest side or opposite of the 90 degrees. You notice that that did not change in this case. It doesn't matter that we're going from angle C here. The hypotenuse is still B. And so the adjacent then is going to be side A. And so when I switched the angle up here from A to C, that meant that I switched the opposite and the adjacent, but the hypotenuse remained exactly the same. One other little trick for naming these that might help you. Remember I was talking about the naming conventions? The angle and its opposite side always share the same letter name. The only difference is that the angle is capital and the side is lowercase. But otherwise, that's the only difference between them. And so those will always be opposites. So if I give you some triangle that you cannot see and I say you're going from angle P, what side is opposite? Lowercase p will always be the opposite side name. Now you might be wondering, what if we go from angle B? What do we call it then? Well, this actually gets a little bit tricky because if we want to know the opposite side from angle B, notice that's side B, which is also the hypotenuse because that didn't change here. And so we're actually going to find that we're never going to be told that we're going from angle B as our angle because it always has to be one of the other angles that we go from. Remember how these have to rely on it being a right triangle? So we already have to know that one of our angles is 90 degrees. It's just a matter of what the other two are, which one of the other two we're going for. So if you were saying from angle B, our right angle, the opposite and adjacent would not make sense to discuss. The hypotenuse still makes sense, but not opposite and adjacent, and you won't be asked for it from the right angle like that. Now we're going to practice another one of these types of problems. Before I go through it with you, take a moment, look this over, figure out what would you call each of these sides. All right, so we're going from angle B. The opposite then is on the far side of the triangle, so that is going to be little b. The adjacent is the one that is next to our angle but is not the hypotenuse, so that is A, and our hypotenuse is going to be C because it is on the opposite side from the right angle. Let's do one more of those. Go ahead and figure out for this one which side is opposite, adjacent, and hypotenuse. For this one, we're going from angle C. Therefore, the opposite, as you can see there, is going to be C. Keep it lowercase. The adjacent is going to be the side that connects to that angle but is not the hypotenuse. You'll notice it always connects the angle with the right angle. So that's going to be A. And then our hypotenuse is B for this one. Now, these are the sorts of problems that you're going to be seeing a lot of as we go through this work, where you're going to be given some angle measure and a side length, and then you might be asked to find another side length. And so as we go through these, we aren't actually going to be solving them. We're just going to be looking to see, would we use sine, cosine, or tangent in order to solve them? And we'll deal with the actual solution process in a different lesson. All right, so for this first one, notice that we are going from angle A, because that's the angle that is actually given to us here. So I would mark angle A. And then you'll notice that I know side A. Now, what do we call side A there in terms of opposite, adjacent, and hypotenuse? Side A would be the opposite. And then notice that we are asked to find side B. And so I look at B here and say, okay, what do I call that side? Is that the opposite, adjacent, or hypotenuse? And that one is the hypotenuse. So you notice here that this particular one involves the opposite and the hypotenuse. To answer this question, then we say which of those three trig ratios, sine, cosine, or tangent, involves opposite and hypotenuse? And the answer is sine, because sine equals opposite over hypotenuse. And so your answer for this one would be sine. Now, later on, we will be solving these out. We'll actually write an equation with that where it'd be like sine of 25 equals, and then it would be the opposite over the hypotenuse, that sort of thing. Just as a little preview about where we're going. But for now, just say sine. All right, next up, let's take a look at this next problem. In this problem, notice we're told that A equals 70 degrees, angle A. So again, I'm going from angle A up there. Then I'm told that side B is 42 units long. So I'm going to be dealing with side B, which is called the hypotenuse. I'm always wanting to label, is it opposite, adjacent, or hypotenuse? And then I'm being asked to find C. And so I go over here, okay, C for angle A would be the adjacent. So I now know that this problem involves the hypotenuse and the adjacent. So then I go back and I say, okay, which of those three trig ratios involves hypotenuse and adjacent? And the answer is cosine. All right, now on to the next one after that. We have A, notice that's a lowercase a, so that means that side length A is 90. So I'm going to be dealing with this as being 90. Side C is 23, again lowercase c, so that's the side length C. And it's asking us to find A, that's capital A. So it's wondering about this angle up here. So that's the angle then that everything is relative to. So then from that angle, what do we call each of the sides? Well, side A would be the opposite. Side C would be the adjacent. So which of our trig ratios involves the opposite and the adjacent? That would be tangent, because tangent is opposite over adjacent. Remember the TOA, T-O-A, tangent equals opposite over adjacent. And so that's how I then know that I would use tangent to solve that particular equation. All right, and then one last one here, where I know that A, lowercase a is 8, okay, so I know that part. And then lowercase b is 12, okay, so I know that involves that one. And it's asking us to find C, capital C, so that's angle C. So then that means that this is the angle that everything has to be relative to when we talk opposite, adjacent, and hypotenuse. All right, now I just see, what do I call the two sides that I'm dealing with? Well, A in this case would be the adjacent, B would be the hypotenuse. So going from this angle, I got adjacent and hypotenuse, which is cosine, because cosine equals adjacent over hypotenuse. As you go forward and you actually work on solving these problems and later problems, your process will be the same as your first step, which will be to decide, will you use sine, cosine, or tangent? Now, one other way that you could see this come up is we actually can figure out what some of these values are. And so we're going to figure out what each of these 6 values are going to equal. And something I want to do first is take a look at the actual problem we have. Notice what we're being asked to find. We're being asked, what is the value of sine A? Now notice, it's not saying what is the measure of angle A. It's only asking us what the sine of angle A would be. And so because of that, I can come up here and say, okay, well, I know that I'm working from angle A, and sine, remember our definition of sine, SOHCAHTOA, sine is opposite over hypotenuse. And so what is the opposite of angle A? That'd be the 12. And so this is my opposite. And what's my hypotenuse? Well, that would be the 20. And so if sine equals the opposite over the hypotenuse, that means that it's going to equal 12 over 20. And that's how we can then figure out what sine of A is. Now, in this particular case, I would like to take it one more step, though, because you notice this fraction of 12/20ths, it reduces. So let's go ahead and reduce it. Looks like I can divide top and bottom here by 4. And so that will give me 3/5. And that is what sine of angle A is. We still don't know what angle A is, but we do know that the sine of A is 3/5. All right, we're going to practice the same idea with the rest of these. Might be a great idea to pause this at this point, though, and try to see if you can do them all yourself now before I talk through them with you. All right, for the next one, cosine. Cosine, our definition of cosine, remember SOHCAHTOA, C-A-H. So cosine is adjacent over hypotenuse. And so I'm again going from angle A. And so the adjacent is 16. And the hypotenuse is still going to be 20. So it's going to be 16/20ths, which reduces down to be 4/5. All right, next up, we got tangent of A. Tangent is opposite over adjacent. And so I'm now going to grab, because this is angle A here, the opposite of A, which is 12, and then the adjacent from A, which is 16, so it equals 12/16, which again reduces. In this case, it reduces down to be 3/4. So we can actually find these sine, cosine, and tangent values because of this. All right, we are going to repeat the same process for the rest of these. So next up is sine C. Yes, we did sine earlier, but that was sine of A. This is now sine of C, which is going to give us a different value. So to go from C then, it's going to be opposite over hypotenuse again, because sine is always opposite over hypotenuse. The opposite of C is 16, and the hypotenuse is still 20. So this is 16/20, which, as we already know because we saw this one before, is 4/5. Notice, those two are the same. Cosine of A is equal to the sine of C. And yes, that would actually always be the case when you're dealing with the exact same triangle like that. All right, let's keep going around the horn then. Next up is cosine of C. So cosine is adjacent over hypotenuse still. And the adjacent from C here is going to be the 12. And so it's going to be 12 over the hypotenuse, which is still 20. So it's 12/20, which reduces to be 3/5. And again, notice the cosine of one angle equals the sine of the other angle. That is a pattern, and that will stay true. All right, last one then. We're now going to be doing the tangent of C. And tangent, of course, is still going to be opposite over adjacent. And the opposite of angle C is 16. And the adjacent of angle C is 12. And so that reduces down to be 4/3. And you'll notice the connection between these two values. The tangent of one angle is the reciprocal of the tangent of the other angle. That is, it's the exact same thing. It's just flipping the fraction upside down. If you can use it with these skills, and if you can apply the sine, cosine, and tangent concepts to these last couple problems we've been working through, then you're ready to go ahead and find some of those unknown values, and you're ready to go.